In enterprise AI, we talk a lot about agentic workflows, AI that can actually do things. But every time an agent talks to a database or moves a file, it uses a digital signature. Most developers do this. They import a standard library like RSA or ECC and hard code it into agent's core. It works perfectly until it doesn't. With the rise of quantum computing, the National Institute of Standards, which is NIST, is constantly updating the math formulas which are safe. If you hardcode your security today, you are essentially building a house where the front door is welded shut. To change the lock, you'd have to tear down the whole house. Let's look at an example. Imagine an inventory agent. The hard-coded way is, inside the Python code of the agent, you have a line that specifically calls crypto asymmetric RSA. This is the wrong way to do it. I'll explain why. Tomorrow, a quantum breakthrough makes RSA obsolete. Your team now has to find every single agent in every microservice, rewrite the code, retest it, and redeploy. That's a 6-month project while your data is exposed. Now, instead of the agent doing the math, the agent sends the message to a sidecar proxy, which can be Istio or a specialized security module. Let's look at this updated code. Here we are using OQS as your open quantum safe library. The agent currently is using pre-quantum mode, and this is the way you are going to get the agent signature. Now let's go for the first agent task and then we'll go for the signature. So here in the agent task, you can see the agent doesn't care about the math. It's an abstraction layer. It will just go for the secure signature. And when it goes for it, it can pass on its instruction and return the signature. Here, if you look at the mode, when you pass in the post-quantum mode, it is going to use MLDSA 65, which is the new NIST PQC standard. And after that, the agent can run the task, which is to transfer the $10K. So essentially, the workflow is that the agent says, I need to sign this order. It hands the data to the abstraction layer. The layer looks at a central policy and says, right now we use MLDSA 65 algorithm. The win part here is, if that algorithm is compromised, the security admin changes just one line of policy in the central controller. Instantly, all thousands of agents start using a newer and the safer algorithm. No code changes, no downtime. For those of you in enterprise AI governance, this is a massive shift. Agentic AI security isn't just about who has access. It's about how that access is verified. If your agents are running on fixed math, they are a liability. By implementing an abstraction layer, you achieve two things. The first is the regulatory compliance. When auditors ask how you will handle the transition to post-quantum standards, you show them your policy engine, not your secure code. The second is operational resilience. You can now test new PQC algorithm in shadow mode, running them alongside the old math to see if they slow down your AI response or they actually work the way you want them to work without you fully switching away from it. The takeaway for today is, don't let your AI agents become legacy tech before they even launch. Abstract your security, stay agile, and stay quantum ready. If you want a copy of my Agentic AI security list to check if your framework is crypto agile, drop a comment below or check in the link in the description. I am Amit and this is a Tiny Tech Talk. Don't forget to like and subscribe for more enterprise AI insights. See you in the next one.